Hey everyone, and welcome back to the channel. Today, we're diving deep into a cosmic mystery that's over 450 years old. Let's travel back to November 1572. A new star suddenly blazed into existence in the constellation Cassiopeia. It was so bright you could even see it during the day. The legendary Danish astronomer Tycho Brahe meticulously recorded this event, and the supernova remnant that now bears his name has fascinated scientists ever since. But what if I told you there's a hidden chapter to this story? A new analysis suggests Tycho's supernova had a far more dramatic origin than we ever imagined. It didn't just explode in the silent vacuum of space. It went off inside the ghostly remains of a planetary nebula. Now, don't let the name fool you. Planetary nebulae have absolutely nothing to do with planets. They are spectacular, glowing shells of gas and dust that stars like our sun puff out at the end of their lives. Think of them as a star's final, beautiful sigh before it fades away. These celestial artworks are pretty fleeting, usually disappearing within a few 100,000 years. This is what makes the timing of Tycho's supernova so mind-blowing. The explosion must have happened while this ancient nebula was still hanging round, creating a rare and incredible phenomenon that researchers have dubbed a supernova insider. Planetary nebula, or ASNIP for short. So, what's the evidence? Well, it's written in the very structure of the supernova remnant itself. If you look at images of Tycho, you'll notice two distinctive opposite protrusions sticking out from the main shell. Astronomers have nicknamed them the ears. These aren't just random bumps, in fact. They look remarkably similar to features found in 3 other Type A supernova remnants. Previous studies had already flagged these other remnants as potential SNIPs. This new analysis strengthens the case that Tycho is part of the same exclusive club, finally confirming a theory that was first proposed all the way back in 1985. It's amazing how a 40-year-old idea can suddenly come roaring back with no evidence. So what does this tell us about how these explosions happen? Tycho was a Type A supernova, which occurs when a white dwarf, the superdense, burnt-out core of a dead star explodes in a massive thermonuclear blast for decades. Scientists have debated the exact trigger. The SNIP discovery points strongly towards a specific model called the core degenerate scenario. Picture this. A white dwarf spirals into the gassy envelope of its companion star and eventually merges with its core. The big boom doesn't happen right away. It happens later, but crucially, it happens while the planetary nebula created during that initial stellar dance is still visible. It's a multi-act play of cosmic proportions. Here's where it gets really revolutionary. If Tycho fits this pattern, and if we start finding similarities on other supernova remnants, it means that SNIP might not be the rare exceptions we thought they were. They might actually be the norm. The new research proposes that a staggering 70 to 90% of all normal Type A supernovae could be SNIPs. This completely changes our perspective. It means the vast majority of these universe-shaking explosions happen inside the fading, beautiful shells of planetary nebulae. This also suggests that these supernovae don't only happen over ridiculously long timescales. They can occur in relatively younger stellar populations where the nebula hasn't had time to disperse. Yet, it's just incredible. A cosmic event witnessed over 4 centuries ago is still revealing secrets, forcing us to rethink our fundamental understanding of how stars live and die. Tycho's supernova isn't just a piece of history. It's an active classroom in the sky. Thanks so much for joining me on this journey into the heart of an exploding star. What do you think about this discovery? Let me know in the comments below. If you enjoyed this deep dive into the cosmos, please hit that like button, subscribe to the channel, and ring the bell so you don't miss our next adventure. See you in the next video.